This is for Year 11 methods. It comes out of Chapter 10. It's 10.7, question number 6. Kiara is walking her dog. She leaves home and walks for 10 minutes at a constant rate to a park 60 metres from her home. So it's the first bit. She ends up 60 metres from home after 10 minutes. She then stops at the park for 5 minutes and sits down while the dog runs around. She then runs home at a constant rate, taking 5 minutes to get there. Draw a distance time graph. So this is going to be t. This is going to be the distance with respect to t. I'm going to call it that because they told me to. So I know that after 10 minutes she is 600 metres from home, and she started at home and she walked at a constant rate. So that's going to be a straight line like that. And where that's going to be 10 and 600. Then she sat down for 5 minutes. So after 15, she's still 600 metres from home because she sat down and didn't move anywhere. And then she runs home at a constant rate, but it only takes her 5 minutes to get home. So at 20, she's now back at home. So there's my distance against time graph. Part B, determine if at any point d of t cannot be found. If at any point d of t cannot be found. Well, d of t cannot be found when t is less than 0 or t is greater than 20. That's the times that d of t cannot be found. Determine if any derivative cannot be found. Okay, in part C, the derivative, so d dash of t, cannot be found at sharp joins, so it cannot be found here or here, and it can't be found at endpoints here or here. So d of t can be found from 0 to 20, not including 0, not including 20, and I'm going to exclude 10 and 15. So that's where it can be found. Where it cannot be found, 0, 10, 15 and 20, it cannot be found. Part C, write down the rules for the hybrid function d of t. Okay, in part D, d of t equals 3 different rules for different circumstances. When t goes from 0 to 10, when t goes from 10 to 15, and when t goes from 15 to 20. And in the middle bit, it equals 600. In the first bit, rise over run, it goes up 600 and goes across 10, so that's 60 t plus 0 because the y-intercept is 0. And during this time here, rise over run, it goes down 600 but only over 5, so that's going to be negative 120 t. Now y equals negative 120 t plus some constant c. I know that it is equal to 0 when t is equal to 20. 0 equals minus 2,400 plus c, therefore c equals 2,400. Therefore plus 2,400. Okay, that's an expression for d of t. And E, find the derivative for all possible values of t. Okay, I'm just going to get rid of this bit here. Okay, to do part E, I want d dash of t. That's going to equal, the derivative of this will be the derivative of this, or 60, when t goes from, notice I haven't included 0 and I haven't included 10. And it equals 0 when it goes from 10 to 15, and includes negative 120 when it goes from 15 to 20, but not inclusive of any of those, because on the endpoints and on the sharp joins, the derivative doesn't exist. And that's it.